Solving problems about uniform motion, so things that are going the same speed over the course of, while they are in motion. So say for example, we're given that we have two trains leaving a city, traveling in opposite directions. One train travels at a rate of 80 kilometers per hour and the other at a rate of 75. How long will it take before they are 387.5 kilometers apart? So, if you want to pause this to write things down, you can. I'm going to go back to my paper to solve it. So first off, we know we have these two trains, they're going opposite directions. So we have train 1 going this way, train 2, and we want to know at what point or how long will it take to make this total distance this far. We know train 1 is going 80 kilometers and train 2 is going 75 kilometers. Key thing is they're both going the same unit of speed. So if one was in miles per hour and one was kilometer per hour, we can't compare them till they're in the same unit. So these are the same, we don't have to change them. We know that distance is equal to rate times time. So if we set up a handy little chart, word problems, I'm going to put in a plug for it now. Word problems I love to do with charts. Distance equals rate times time. So we know train 1, 80, train 2, 75. They go the same amount of time, but that's what we want to know. And if we times these two, because rate times time is distance, 80 times x is 80x, 75x. So we know if we add these two together, we want a total distance of 387.5. So 155x equals 387.5. Divide both sides by 155. And we get that x equals 2.5 hours. That's how long it will take those trains going in opposite directions to reach the total distance of 387.5 kilometers. So, what if instead we were given something like this, where our problem is Michael Good can drive to work in half an hour. When he rides his bike, it takes 1.5 hours. If his average rate of driving to work is 30 miles per hour faster than his rate while bicycling, determine the distance he lives from work. So we want to know distance this time, right? Well, let's first set up our chart. So, coming down here, we have distance, rate, time. We know we're talking about biking versus driving. And we know when he drives, he goes some rate, x. But he goes 30 miles per hour faster when he drives. So x when he bikes, 30 hours faster when he drives. He takes half an hour when he drives, and 1.5 hours when he bikes. If we times this across, I get 1/2 x plus 15 and 1.5 x. These two things should be equal to each other because he's going the same distance whether or not he bikes or drives. Minus the 1/2 x minus the 1/2 x. And we get that x equals 15. Well, this doesn't mean he lives 15 miles from work. This means he goes at a rate of 15 miles per hour when he bikes and 45 miles per hour when he drives. Which, to find the distance, we need to plug it into one of these two. So 1.5 times 15 is equal to 22.5 miles. And that's how far that Michael lives from work.